Hi viewers, I'm Paul Dvorak, editor of Windpower Engineering and Development magazine.
And I'm Michelle Froese, senior editor of the magazine. We're here with Paul, and he has just recently come back from the American Wind Energy Association's Offshore Wind Conference. So let's find out from him what the conference was like. Paul, tell me a little bit about your time there.
Well, first of all, the mood of the conference is quite upbeat, and that's because off Block Island, Rhode Island, there are now 5 foundations in the water. So the American offshore wind energy is not just a concept or an idea, it's a real thing now. There are a few more attendees at this year's conference, and there are about 20 booths, so there's a trade show element of the show as well.
That's great. So what's the general outlook for the offshore wind industry in the U.S.?
So it was quite positive, quite positive. A lot of the funding has been provided for several wind farms on the East Coast, and I mentioned the 5 foundations in the water now. Next summer, 5 turbines will be mounted on those. There'll be about 6 megawatts apiece, so there'll be a 30 megawatt wind farm.
Exciting news,
first.
For sure. What other projects are planned for the future?
Off the East Coast, there are about a half dozen, 6 planned. One planned for Lake Erie called Icebreaker, and there's one floating wind farm planned for offshore Oregon.
That's great. So why does offshore wind make sense for the United States?
That's a good question. First of all, a couple of reasons. First of all, the capacity factors will be higher. For example, in Europe, they have subtler winds than the U.S., so the capacity factors for the turbines there are about 28%. Get to the American Great Plains, U.S. Great Plains, and the capacity factors jump from 30 to 40%, which is significant. But you go offshore, and the capacity factors start reaching up to 50%. So there's a lot more power to be harvested there. Second big advantage is the wind farms will be much closer to load centers, the cities that need them. Okay, so the onshore wind farms need many miles of expensive cabling to get the transmission, to get the power to the cities. Offshore, there'll be just a few miles.
Makes sense for sure. Yeah. What goes into selecting the foundations for offshore wind turbines?
It's all in the seabed geology. In Europe, they have rather shallow waters in the North Sea, so they can get away with monopiles. These are just large tubular structures that are rammed into the sea floor about 40 meters or so. They can mount a turbine on that. It's different in the U.S. The water is deeper. So Block Island, that we mentioned earlier, will have they're called jacketed structures. These are 4 legs, 4 feet, set in the water with some screws of some sort, anchoring bolts of some sort to hold them to the seafloor so they don't move. In Lake Erie, the Icebreaker project will be using something called a suction bucket. And it'll be a large 15-meter diameter bucket, inverted with a monopole rolled to the top. The bucket will sit on the lake bed floor, and the water will be pumped out, and the differential pressure will push the bucket into the lake bed. And Universal Foundations in Denmark, who developed this, have developed some other features in the bucket that allow adjusting it as it goes into the seafloor. So they will be able to get that monopile at the top within a ½ degree of vertical, which is perfect. That means they can get rid of a transition piece that ordinarily is made to make up for the lack of vertical accuracy.
Really interesting. Thanks, Paul. So what safety factors are there to consider that make it different from, say, offshore versus onshore turbines?
Yeah, there's an element of risk added to offshore work because you have the water, and it's not always calm. So first of all, you get to the turbine, you have to put all your heavy equipment in a boat and get up to the turbine site, and then transfer from the boat to the foundation. And that's going to be somewhat difficult. The Europeans have solved that. I've seen a couple boats over there that have gangplanks with hydraulic devices on them that will sense the motion of the boat and correct the gangplank movement so it's rock solid. So the technicians can grab their gear and walk on as if they were on land, right to the turbine towers, and then finish their work.
Wow, well that's all great news. Thanks, Paul. That's all we have time for today. But for more wind videos, please visit windpowerengineering.com. Thank you.